Thank you for coming back. I've got good news for you. That is, we are going to have Transformer 2 this morning. Yesterday we did on Transformer 1, and we are going to study something else in this second section of my lesson. Now, the most important thing is that I know that you can be transformed. You will be changed, you will improve in your physics, and you will understand Transformer better after this lesson. But remember, whatever you do, you must always practice and practice, answer questions, get your notebook, get your pen and pencil, and start writing and answering questions. That is the way forward. That is the way to improve in your physics. Now, at the end of this lesson, you should be able to solve problems involving transformers, especially using this particular formula. Specifically, you are going to use this formula to study this section of transformer. This is the question. Diagram 7 shows a simple transformer. Have a good look at the transformer. On the left-hand side here, you have the input. Now, what is another word for input? The primary coil. And on the right-hand side here, you have output. And what is another name for output? Secondary coil. So remember the two words, primary coil on the left-hand side and secondary coil on the output side. Now, another term for revision. If I were to ask you, what kind of a transformer is this? You should be able to tell me the specific name for it. It is a step-down transformer because from 240 volts, we step it down to 6 volts. Let us look at the question now, the second part of the question. The current in the primary coil is 0.1 ampere. And the efficiency of the transformer is 75%. Calculate the output power of the transformer. Are you ready to do your writing now? Now, once again, we look at this transformer diagram and we want to tackle the question. We want to calculate what is the power on the output, on the secondary coil. I'm going to write down a few important things now. First and foremost, I'm going to highlight it. All right. I am highlighting the most important parts of the diagram. Okay. The input and the output. All right. A little bit of revision now. We are going to write down what is the name of this transformer? It is a step-down transformer. Alright, so far so good. I'm going to write down two more terms on the left and the right-hand side of the diagram. The input, just now I mentioned that it is also known as the primary coil. So the primary coil is the input. And what about the output? It is called the secondary coil. Now pay attention to the alphabet P and the alphabet S. Let me use another color. All right. Because in our formula, as you would have noticed, we make use of IS, VS, the S stands for secondary. IP, VP, the P stands for primary. And sometimes in the equation, you can use, instead of secondary, you can write down output. It is perfectly alright. It is just the same. And for primary, you can write down the word input if you prefer the word input. Okay? Let us get back to the question now. Take note of this. The first part is the current is 0.1 ampere in the primary coil. So we must write down IP. The current in the primary coil is 0.1 ampere. And in the diagram just now, what is the voltage or the potential difference in the primary coil, which we call it as VP. Alright, look at the diagram again. Now, what do we have? Input 240 volts. It is important for us to write it down. 240 volts here is actually the VP. Alright, and output 6 volts is actually the VS. Alright, it's the secondary. So we come back to this question now. So the VP is 240 volts. Alright, so I have one term, two terms. Now what else is given in the question? Efficiency is 75%. So we write down efficiency 75%. Okay, I will write down efficiency of the transformer is 75%. So far so good? Now what do I need to calculate? The question is calculate the output power. Output power means the power in the secondary coil. Alright? In other words, this refers to the power in the secondary coil. We just call it S. Alright, so far so good? Now we make use of the formula and put all this in. Alright, so the formula says efficiency is equal to, what do we have? ISVS divided by IPVP, or you can put VP, IP, anyway round is okay, it's the same, multiplied by 100%. So this is the equation that we are going to solve, and from here we can work out the answer. Okay, let's proceed. This is the same equation here. Alright, this is the same equation here. Alright, the same diagram. Alright, now let's put in all the values. Alright, let me write it down again. Just now efficiency, it is 75% equals to ISVS divided by IPVP multiplied by 100%. This is very good. We write it again, it is good practice. Now what I have to do now is, I want to calculate the power output. Which is the power output? This one. What I'm going to do now is, I will write the equation again. I will change one thing at one time. IPVP is actually, IV is power. P equals to IV. Alright? So, remember that generally speaking, power equals to IV. So, IPVP is actually the power of the primary. Alright? The primary, the primary is the input. What do I want? I want the output. Alright? Okay. So remember, this is the power of the input, and this is the power of the output. Alright? I put the subscript. Multiplied by 100%. Okay? And the power input, the values are given. Power input equals to IV, IPVP. So I should use this term and put it down here. Alright? So this is another equation that you can use from time to time. All right, if you do not want to put IV, you can put it down here. Okay, so which are the values that I am given? I am given IP, I am given VP. All right, so what I do is I put down IP. What is the value? IP is the current in the primary, 0.1 ampere. I multiply it by the voltage in the primary, which is 240 volts. You look at the diagram, you will get the value. All right. So here we are. It's almost finished. So from this equation, the only thing that we need to calculate now is power output. So the power output, which is the power of the secondary coil, is equals to 75% divided by 100%. I multiplied by 0.1 ampere multiplied by 240 volts, and I would get my answer, which is exactly 18 watts. All right. So this will be my answer to the question. Okay. So basically, all you need to do is to know the formula, substitute the values in, and the trick here is to know that earlier on, ISVS is actually the power of the secondary coil, which is the power of the output. And that is what we want. Okay? So that is the answer to the problem. And after you have done this, I am sure you have understood another aspect of transformer. You can calculate the power output. You can actually calculate other quantities if required to. All right? So with this, I know that you will try out other questions, and after that, you will improve further. All right? So with that, I would like to thank you very much for being with me, and I'll see you again. And may God bless you in your progress. Bye.